so the review for Unit 4, Lessons 1 and 2 is starting now. So this first set of questions, is based on sets and basic probability. Our experiment is to draw a card from a 52-card deck, replace the card every time. You don't have to write all this, guys. So go ahead and use this information, and go ahead and we're going to answer 1, 2, and 3. Our two events. Event A is draw a diamond. Event B is to draw a jack. Okay. So first, describe the sample space. First, you or your. Actually, we're going to work independently. If you need to check with your neighbor, if you forgot what a sample space is, check with your neighbor. But what is a sample space? Just describe it. I didn't put brackets here because I don't expect you to write all of them out. And that's enough of a hint. So I'm going to give you, for this, I'm going to give you 5 minutes to work through all these. Don't forget that all of our probability formulas are over on the right side of the board over here. And these are going to be accessible. So I'm looking here and I just say, well, the union of A and B, isn't that just everything? No, it's a probability of that. So let's look over at our connected events formula. Okay. So that is starting over there. And I'll give you 5 minutes starting now. And we're back. Great. All right, so if I have a die, if I have one die, name off all of my sample space.
1, 2, 3, 4, 5, 6.
That was quick. 1, 2, 3, 4, 5, 6. All the options, the total options possible. That's my sample space. That's also called the universal set. And it's talking about every single bit. I said describe because otherwise if I would have put my brackets, I would expect you to go,
4.
Spades ace, spades 2, spades 3. And that isn't really, that's just rote memory, just like jotting it out. So how can we describe the sample space? Just describe it.
All 52 cards.
All 52 cards. You have to know the sample space because all of the ratios, all the probabilities we're doing have the denominator. The bottom number is, it's out of 52 cards. Since we are replacing the card, if I wasn't replacing the card, the next one would be out of 51. The next one would be out of 50, and so on. I'm replacing it, so I know that the sample space is all 50 cards, and it's going to be the denominator for all of my probabilities. The probability of A, let's look to see what A is. To draw a diamond, I'm going to go ahead and do them out. Diamond, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king.
That's 13.
How many options?
13.
13 out of how many total in my sample space?
52.
52, which makes it 1/4 because it's 1 out of the 4 suits. Okay. There's a bunch of ways to look at it. 25%. What's that? I don't know. So we're looking for percentage probability. 25% chance. Not that great of a chance. Yeah, I want the answers in a percentage. Okay, and then we look to the probability of A union B. A union B, I'm not just asking for what element is A union B. I need to see the probability of all the probabilities of A or all the probabilities of B. Okay, let's see. Draw a jack. How many options?
4.
1,
For
2,
one of them.
3, 4.
So
This is special.
So yeah, we got that's just 16. It's just gonna be 16 because you don't need that one because that one already been covered by the other one.
All right, so we have the probability of A. I'm going to put it in the form of 52 on the bottom.
Yeah, always got it.
Plus, what is the probability of getting B, drawing a jack?
4 to 52.
4 to
4 out of 52. 1, 2, 3, 4. 4 out of 52.
Yeah.
Okay, then we have to subtract. Just like we were paving the road, we were paving Fruit Ridge and
You gotta go.
Stockton.
Get rid of
We're
that
paving the 2
intersection.
roads.
The intersection don't matter.
The intersection, you don't want to pave the intersection twice. So we have to take out what is in common. It doesn't matter.
Matter for different thing, not this.
Too much commentary. Too much
It
commentary.
matters half as much.
Let's bring it back. How many intersection points points do we have?
1.
We're going to minus 1 out of 52. So it's out of 13 plus 4, 17, minus 1, 16 out of 52. What percentage is that?
30.8.
Which is more probable?
I'll
A union B, right? Slightly more, because think of it this way. If I just had the probability of A, that's all my blues, right? The probability of A union B is going to just have more options because I have more cards that I want to select. The desired cards have increased. We always have to subtract out that intersection. And remember, this is for connected events. We're not yet getting to conditional events. That's the next two segments. Okay. So it will be broken down like this. The review tomorrow will match the same segment format. Okay, any questions on this one? Okay, don't try to wing this test. Don't try to wing it. Because I'll tell you,
I'm gonna wing it.
I'll tell it. Some people wing tests.
Man,
You
always
guys don't know what that means?
Man, always
You know
win.
Pretty much my.
That's your MO?
Man got wings.
All right, listen up,
Fly.
listen up. After the spring break, we have 1 week, but I'm going to do the second portion of probability, which will be 2 weeks long. So this is the last quiz we'll have before the quarter. So don't say, I'll try to get this, I'll wing it, and maybe I can wing the other one and improve my grade. You got to go pretty hard for this one, okay? All right. Is there?
Is our quiz with?
When's our quiz, guys?
Wait, how much is it?
I don't know the point about it yet. Yeah.
What if it's minimum day?
We still don't know about that. That's the point.
Right, we don't know about that. So I made the test where we can accommodate that if needed. That's where I would take out some of the questions. It's weird not knowing that and having designed the test already. So we'll see. But it's, again, so mostly conceptual. We're going to have these kind of diagrams on the actual test that you can cross out and do all that. I have all this on the test too with the actual cards. So I think it's going to help you to be quicker than, a lot of this is just having to write down the models twice. All right, this is the second part. And for this, I need well, actually, let's see. The person next to you, you're going to share this with them. You're not going to work in partners, but you're going to share it. So I need one person to come up and get a playing card and 2 markers. And I'm going to pause it 1 second. Here we go. So for this next segment, we're looking at conditional events. Again, that is an event where it's the probability of B given that A has already happened. Okay. We're for that going to use our conditional event formula, which I put it here just for you. So our experiment is roll 1 white die and 1 red die. So we have our little playing boards here. And remember, this is the one where we in one color did all of the event A, rolling doubles. All of event B, rolling evens. And that's going to help us really quickly input what we need into this. So we have on the bottom, it's always the given. It's always the given. The second event, the probability of that event over or under the probability of the intersection of the two. So using the color coding is going to help you arrive at that pretty quick. I want you to find the probability of B given A and A given B. So I'll give you 5 minutes for this, and then we'll come back and review. All right, go. Here we go. So first off, we had to find the probability of rolling evens given that you rolled doubles. So this card that you have, you'll be able to, you will have that kind of already on the worksheet for the quiz, so you'll be able to access that tool. Now, what is the probability of the given event? Remember, that's always second in our notation, and that is what goes as a denominator. So rolling a double, how many options out of 36 did we have?
6.
6. All right. On the top, we're doing the probability of selecting the option that is an intersection of A and B. How many places did they intersect?
3 out of 36.
3? Okay. Let me do it in a darker color. 1 second. There we go. Okay, so I'm just going to write this again in a dark color.
Yeah, so it's just it.
Trying to erase it. It really
He's a
doesn't
UG.
erase.
It's nice.
It really, no, it really doesn't.
All right, what goes on the top? What fraction? How many times? 3? So we work this out. If we did the, I'll just do it out once. So we end up with 3 over 36. This is the last time I'm going to show this. It's just doing the flip trick, and then 3/6 is how many?
1/2, which is 50%.
50%. 50%. All right. So it is going to be different. Again, this is where conditional probability doesn't always match what our logic about the situation. It doesn't exactly match that. So the probability of rolling evens given that you rolled doubles is different than the probability of rolling doubles given that you rolled evens. Okay, so we want to make sure that this is, like we said, set up. Some things are going to be the same. What's going to be the same between working these two out? What's going to be the same?
Top one, the intersection is always
The
gonna be
intersection.
same. Intersection, always the same.
The intersection of Fruit Ridge and Stockton versus Stockton and Fruit Ridge?
Same.
Place. So I know that on top we're going to have 3 out of our 36. What is the probability of B? Let's see. Rolling evens, what do we have? 9. 9 out of 36. Again, you could work the probability out just based on the number of options. I just have you do this to have it uniform throughout. We're always using the probabilities here. 3 over 9, 33%. Okay, which event is more likely to happen? B given A or A given B? B given A. Probability of B given A, because it's a 50% chance versus 33% chance. All right? So that's our answer for 6. Okay. So I hope this starts to narrow the scope a little bit of what we need to focus on. Done 2 weeks of topics, so a little bit extra. Here we go. This is number 7, 8, 9, and 10. Let me introduce it to you first. So with this one, we have, good. Okay, we have a frequency table and conditional probability. Okay, so the focus, most of it is in conditional probability. Fill in the table first. We have 9th and 10th graders. We also have, they select, so we're going to choose one student from random. That's our experiment. So we're select one random student. So we're going to select one random student. We need to fill in the rest of the table. This was a basic question where they're saying, do you like breakfast or lunch better? Okay, which one do you like? So we have to fill this out. Think of the Sudoku, what goes where. That'll help you get to the next little bit. Our events are going to be 9 is 9th graders, 10 is 10th graders, B is breakfast, L is lunch. And then for 8, we need to find the probability that we select a 10th grader given that the person likes lunch. Number 9 is select a lunch person given that they're a 10th grader. They look like they might be the same, but they aren't. And for honors, I also want you to see if this is independent. So I want you to see it, just this one. Is this independent? So there's actually 11 for you guys. All right, for this, I'm going to give you guys 7 minutes. So let's do 7 minutes and then we'll wrap it up. All right, work with your neighbor if you need it. Here we go. All right, so looking at this, we're now on the final frequency table. Who could tell me which blank, or what goes in this blank down here? 19, it's just adding these two together, 19. And then here, 8, that helps me get this.
Which also has to be 8.
Helps me get that. Okay, just like a Sudoku, we found the parts that are missing. Now, looking at this, find the probability of it being a 10th grader given that they like lunch. So we're going to look here and basically, move it up here. We're going to put the probability of the given on the bottom, the probability that they love lunch. Forget it. Forget that they're a 10th grader. Just if I said, what's the probability that a student loves lunch? What is it going to be?
16.
Lunch, 16, and I'm going to do them all in probability, so 16 out of 35. On the top, we're talking about the, where did it go? We have it right here. We have the the intersection of A and B. So if you're not sure where to find this,
Is 8.
once you get the bottom, the top is just finding where those things intersect on the table. So we have, let's see, what was it, 10 and L, 10, L, 10 and L intersect, 8. 8 out of 35. We get 8 out of 16, 50%. 50%. Okay. Next, we have the opposite. So we're doing the probability of the given, the second thing on the bottom. Probability that the student is a 10th grader. There's 23 10th graders. 23 out of 35. And then on the top, what is the intersection of L and 10? 10, L, it's 8. It's always going to be the same when you're comparing two things with just the given and the desired switch. So there are 8 of 35. Again, to find the top part, you're only doing the intersection of the two. So we get 8. Let's see, 8 over 23. Percentage, Daniel?
Let me hit you with that.
Who has it handy?
I got it right here. 66.6%. Wait, what? Wait, was that 8 over 12?
8
Oh, 8 over 20. The wrong number. Yeah, what he said. That's probably better.
Oh, okay.
Sorry, I had the wrong number on hand, you know.
No worries. Here we go. So the probability of lunch given 10th grader is 34.8%. Which is more likely between these two conditional events? Probability of 10 given lunch, we're going to put down here. So that's the probability of 10 grader who selected lunch as well, given that they liked lunch. Okay. Now for this, we have to find the probability and see if it's independent. This was another problem you had to do, number 11. The probability of 10 given L is 0.50, and we want to see, is that equal to the probability of 10? Again, remember this. If the probability of 10 given L is the same as the probability of 10, then that given L had no effect, and it would be independent. They'd be independent. If there's more than a 1% difference, and these things aren't equal, then they are dependent, and you'll have to describe it. Slightly dependent, dependent completely. All right, so what is just the probability of getting a 10th grader? Probability of a 10th grader? Let's see if it's equal. 23 divided by 35. Who has that one? How much?
Yeah.
0.65?
Yeah.
Okay. So is this true?
No, that's not true.
It's false. This is not true. It's false. So I know that it's dependent. And it's very dependent because you have quite a big of a difference with those outcomes. So if it was equal, then it would be true, it would be independent. And since it's false, it's dependent. All right, that concludes it for today. Tomorrow the Kahoot review will be a similar exercise. All right, 123rd gets a package of Oreos. Subscribe. I'm at like 96.
96.